Hello everyone, I'm Lee. In this video, we are going to focus on how to define a class, implement a class, and use a class. So I'll use bank account as an example. So you define a class, bank account, and pay attention to this semicolon. Very similar to struct. You need that semicolon too. And with struct, everything inside the struct by default that's public. But everything inside of a class, if you don't say anything, everything is private. So that's a big difference. So in this class, we have two sections. We have private section and we have public sections. And with private section, private means it's private to this class. So this variable called double balance, it's available within this class. So that means all those functions, they have direct access to this balance because it's within this curly brace. So private means private to this class, and outside of this curly brace, nobody can have access to balance directly. They have to go through this public interface. So now let's look at this public interface. We have two constructors called bank account. And look at constructors, they don't have a return type, not even void. And they have exactly the same name as a class name. Exactly the same name as class name. These constructors are overloaded because they have different parameter lists. You can have more than one constructor. And the access functions, they are used to provide access to the private data. So, for example, get balance is going to return the balance of the bank account, and the print is going to print the internal state of the bank account. And the mutator functions are used to modify the internal data. Deposit and the withdrawal will modify the balance. So, pretty much, when you look at a class, the private part, usually we put all the data member in the private part. This is called the encapsulation. You encapsulate data so that the outside world don't have direct access to this data. If they want to access this data, they have to go through your public interface. And as a public interface, you provide ways to access your data, provide ways to modify your data. But if you don't want this data to be modifiable, you just don't provide any functions there. Any mutator functions there. So that's the definition of this bank account. And now let's take a look at the implementation file. So before we look at the implementation file, there's some terminology. Those are called constructor. Those are called member functions. And this one are called instance data member. So instance verb. Instance variable means when I create different instances or different objects of the class, each object maintains their own instance variable. That means if I have bank account 1, bank account 2 of bank account data type, they have their own balance. Okay, so now let's look at the implementation file. In this implementation file, we first implement the constructor. The constructor are used to initialize your internal state. In our case, the internal state only has one instance variable called balance. So when they don't give you any preference, we use 0. You can use any value you want. You just need to document it. And another constructor, this one, when they invoke you by passing a double init balance, you're going to use this value to initialize your instance variable balance. And the get balance simply returns the balance, and the print method, print function, just print this one out to the standard output. And the deposit one will modify your balance, and the withdraw one will modify your balance. And before you do that, you're going to do some kind of testing there. Okay, so now let's come back to this prototype, this header file. And about those two constants, they mean those two member functions won't change the state of the object. So that's a promise. So if inside of those two functions you're trying to modify balance, the compiler is going to kill you, because you said you're going to be constant member functions, which means you don't modify the state of the object. And those two, they're not constant member functions. They can modify the state of the object. Okay, now let's take a look at how to use this brand new data type called a bank account. Now let's look at the test class. So we create an object and we use the default constructor. The default constructor is the one that takes no arguments, and we create another object called account2. We use another constructor. Anytime when you create an object, only one constructor gets invoked. Depends on your parameter list. Okay, and now we can ask this object, say, hey, can you print yourself? This is called send a message to account 1. You have to send a meaningful message, a message that account 1 can understand. So when you say account 1 dot print, the compiler is going to check the type information for account 1, that's bank account. Then it will look through bank accounts definition to see do you have a print there, and we do, so the compiler will pass you. Similarly, when you do account1.deposit, it will first check, say, hey, account1 is an object of bank account, so we're going to check if bank account has a deposit function. We do, and it will check the parameter list. It requires a double value, we give it. So you see, to use a class, you first create objects out of that class. Then you politely send a message to that object. You cannot directly access account1.balance. Take a look. If I say cout let's go ahead and compile this file. Let's say compile. You see, I got an error here. It says cannot access private member declared in class bank account. Very meaningful message there. So you cannot do this. This won't compile. Get rid of this line. Okay, now I'm going to run this program using the debugger to show you the function invocations there. So I'll put a breakpoint here and a breakpoint here, and how about a breakpoint here, just to show you the typical invocation. So I'll go start debugging. Okay, let's take a look. So the call stack, the main function, right now I'm inside of the main function, and account 1. Let's take a look. In account 1 you have balance, which is a garbage value now. So if I press F11 to step into, you see the default constructor get invoked. And now if I step into this one, F11 again, and then F10 to skip over, and you can see the balance now is 100. The innate balance, that's a local variable, that's an instance variable, and your object, the state of the object, this one is the address of the object. It's called this. That's the address of this object, and this is the state, the balance of this object. So I'm going to give it 100. Now it's come to deposit. You see the main function. If I press F11, main function invokes the deposit function in bank account, and the balance, the amount is 100. Then let's take a look at the current balance is 0, but after that deposit, the current balance is 100. Okay, I'm going to run this one. If I give it $20, yeah, it's done. Thank you.